In this tutorial, we are embarking on an exciting journey to build 3 distinct machine learning applications, each one a valuable addition to your portfolio. We will start by diving into a dataset from Chipotle, where we will conduct in-depth analysis to guide the company's business decisions. Next, we will venture into the realm of SMS, where we will create a sophisticated spam detection model. Our final project involves developing a model for breast cancer prediction, leveraging data to facilitate early diagnosis. These projects are designed to sharpen your skills as a data scientist and broaden your understanding of practical machine learning applications. Before we begin, it's important to have a foundation in Python, Pandas, and NumPy. If you are new to this, I've got you covered with tutorials on each. Check the link in the upper right corner to watch these tutorials. Then return here to dive into our projects. Ready to get started? Let's dive in. Alright, so before we start, let's organize our workspace. We create a new folder and name it Tacobell. And then within the folder, we create an index.pymonb file. Index.pymonb. So within this folder, we are going to find this dataset here, Tacobell_CSV. This is the dataset that we are going to work with. You can check the link in the description to download this dataset. Alright, let's define our main goals for this particular project. So first of all, we are going to perform sales analysis, then a customer preference analysis, and then we use a linear regression model to predict the order quantity. And finally, we are going to use the k-nearest neighbor algorithm to find the customer segments based on orders. Alright, so let's create a new code block and start importing all the necessary libraries. So we are going to import Pandas as PD, then we import matplotlib.pyplot as plt, and then we are going to import Seaborn as SNS. Once we are done importing all the necessary libraries, we are going to load the dataset with Pandas. So we create a new code block and create a variable file path, which is going to hold the path of the file. So Tacobell.csv. Alright, so we create a variable Tacobell data equals pd.read csv file, and the first argument is going to be the file path, comma, then we add a delimiter of tabs. Alright, so let's print the first 5 rows of this data. Tacobell data.head. Alright, so this data set contains, I think, 5 columns. Yeah, it contains 5 columns. We have the order ID, quantity, item name, choice description, and item price. Alright, so the item name, we have chips and fresh tomato salsa. We have chicken bowl, and with their corresponding prices and choice description. Alright, so let's create a new code block and then print all the missing cells in each column. So we type Tacobell data.isNone.sum. Alright, so this prints for us all the columns with their missing cells. So we are going to perform some cleaning on this data. So we are going to clean this data before we perform any analysis to it. Inside the choice description column, we can replace all the none with a value like none. And also the price column is having a $sign assigned to each price, making this a string. So we have to strip all these $signs and convert these values into a float. Alright, so we create a new code block and then we type Tacobell data. We select the item price column equals Tacobell data item price, then string dot replace every $sign with an empty string, and finally we convert it to a float as type of float. Alright, so this is going to replace all the $sign with an empty string and convert all the item price column into a float. Next, let's type Tacobell data. We select the choice description column dot fill NA. We are filling all the missing cells with the keyword none, with in place of true. Alright, so let's create a new code block to perform our sales analysis. So we create a new variable sales analysis equals Tacobell data dot group by item name dot aggregate. Then we create a variable of total orders equals pd dot named aggregate. We pass in a column name of quantity and an aggregate function of sum. We do same for total sales. So total sales equals pd dot name aggregate, pass in the column of item price with an aggregate function of sum. Dot reset index dot sort values by total sales in ascending order of false. Alright, so let's print the first 5 rows of our sales analysis data frame. So we type sales analysis dot head and then run our code. So we have here chicken bowl with 761 orders of this amount of sales, followed by chicken burrito with 591 orders, followed by this amount of sales, and this is arranged in descending order. So we are going to create a pie chart to give it a clear representation of this data. Let's create a new code block. Then we type plot.figure, figure size of 10 and 6. Then we plot the pie of sales analysis of total sale with a label of sales analysis with item name. Then we add this one. So we create a plot title, total sales distribution by item name, and then plot.show. So this gives a clear representation of the total sales by item name. Alright, so next is our customer preference analysis. So we create a new code block. So here we are going to create a variable popular items, which is going to be the first 5 rows of the sales analysis data frame. Then we group item name, then we check in the dataset and group all item names which are in the popular list. Popular items sales analysis dot head. We get the item name. Alright, then we type Tacobell data. We select the choice description is in of popular items dot group by the item names of our choice description dot value count dot head. Alright, so this prints for us the most popular choice description based on the item name from the customers. Alright, so next, using linear regression, we are going to predict the item price based on quantity ordered. So from sklearn.linear model, we are going to import linear regression. Then from sklearn.model selection, we are going to import the train test plates function. Alright, so let's create a variable to hold our features and another variable to hold our target. So our feature is going to be the item price and our target is going to be the quantity ordered. So let's create a variable order data equals Tacobell data. We select the item price, then order quantity equals Tacobell data. We select the quantity. Alright, so provided we have our features and targets variables, we can train our linear regression model. So let's create a variable learn regression, which is going to hold the linear regression model. So linear regression, then linear regression dot fit. We pass in our features, which is the order data, and our targets, which is the order quantity. So this fit method is going to find the relationship between the order data and order quantity and find the best fit line through the entire data set. We are going to split our data set into two, the training and the testing data set. So the training data set is going to be 80% and the testing data set is going to be 20%. So strain, stest, we have ytrain, ytest. So we call our train test plate function, which is going to accept the order data, which is the feature, and our target values of order quantity. We pass the test size of 0.2, which means we are going to use 20% of the data for our testing. Then we pass random states of 42. Alright, so we are going to create a variable yPredict, which is going to hold the predicted values of our test dataset. Alright, so let's plot this dataset by typing plt.scatter. So we have strain and ytrain and give it a color of blue and a label of training dataset. We type plt.scatter. We pass in the test and ytest of a color red and give it a label of testing dataset. So now we plot S test against the Y prediction. So plt.plot S test against the Y predict. Let's give this color of green and a label of linear regression. Let's give the X and Y label a name. S label item price, Y label quantity ordered. Then a title of item price versus the quantity ordered. Then we can do plot.legend and plot.show. Alright, so let's run this code. Alright, so this shows us the relationship between the item price and the quantity ordered. Finally, let's create our customer segmentation based on orders with the k nearest neighbor algorithm. So click on code. Alright, so here we are going to import the k-means algorithm from the scikit-learn library. So from this sklearn.cluster, we are going to import the k-means algorithm. Alright, so let's aggregate the data by order ID. So we create a variable order data equals Tacobell data dot group by order ID dot aggregate. We have the total items, which is pd dot name aggregate of column, the quantity with sum with aggregate function of sum, then total spent equals pd dot name aggregate of the column item price with the aggregate function of sum. Dot reset index. Alright, so we then apply k-means clustering with the aggregate data. K-means equals k-means of n cluster equals 3. So this is going to create 3 clusters. And then we have our order segment equals k-means dot fit predict order data with total items and total spent. Alright, so this code here is going to plot the k-means cluster for us. So let's hit on run. And there we have it. So based on this data here, the company can give coupon discount to these users to encourage them to spend more, and give discount to these users to encourage them to spend more. Alright, so let's create the workspace for the SMS model. So we create a new folder for SMS. Then we create a new file, index.ipynb. So the goal for this project is straightforward. We are going to classify a message as a spam or not a spam. So when we look at this data set, we have messages classified as ham and spam. After we are done creating our model, you should be able to differentiate whether a message is a spam or not a spam. So we start by importing all the necessary libraries. We import Pandas as PD from sklearn.model selection. We import the train test split from sklearn feature extraction. we import count vectorizer, and from sklearn naive Bayes we import the multinomial naive Bayes algorithm. Then we import accuracy score and confusion matrix from sklearn.metrics import confusion matrix and accuracy score. So we import matplotlib.pyplot as plt and import Seaborn as SNS. So let's create a new code block. So next we are going to load the SMS file. So we create a variable file path which is going to hold the spam collection.txt. Then we create a variable data equals pd.read csv file path except of tab, a header of none, and names of label and message. So data.head so this is going to print the first 5 rows of the dataset. Alright, so let's pre-process this dataset. We create a new code block and then we create a variable strain test ytrain and ytest equals the train test plates function, which is going to use the label as the target and the message as the feature. So data message data label, then we pass in a test size of 0.2 and the random state of 42. So this data is in a string form and machine learning algorithms are not able to learn from test data. So we have to find a way to convert these tests into a numerical values. So that is where the vectorizer comes in. So we create a variable vectorizer equals count vectorizer. We pass in the stop words of English. What this is going to do is to skip common English words like and, the, and is. So we are going to create 2 variables now, strain vectorizer and test vectorizer. So strain vectorizer equals vectorizer dot fit transform of strain, then test vectorizer is going to be vectorizer dot fit test. So this is going to convert all the string data set into numerical values. Let's print strain vectorizer and hit on the run button. So there we have it. So let's create a new code block to initialize our multinomial naive Bayes algorithm. So we create a variable model equals multinomial naive Bayes algorithm, then model.fit strain vectorizer and ytrain. So let's run this code and then create a new code block to make predictions and evaluate our model. So y_predict equals model.predict text vectorizer, accuracy equals accuracy score of ytest and ypredict. then a confusion matrix equals confusion matrix of y tests and y predicts. Then a variable for actual count, y test dot values count, predicted count, pd dot series, y predict dot values count, and then final variable df count equals pd dot data frame of actual count versus predicted count. Alright, so let's run this code and then create a new code block. So here we are going to plot a bar chart to visualize the actual count versus the predicted count in the classes. So df count dot plot of kind bar, then plot title actual versus predicted class count, plt.slabel of class, plt.ylabel of count. Then we type plt.show and run the code. Alright, so this shows us the visualization of the actual versus predicted class count. Let's create a function which is going to accept a message as an input and classify it as a spam or not a spam. Let's create a new code block. So we define a function classify message which accepts a model, a vectorizer, and a message. So message vectorizer dot transform message prediction equals model dot predict message vectorizer and return prediction. Alright, so let's create a variable prediction equals classify message. We pass in the model, the vectorizer, and a message. So let's try something like, hi, how are you doing? And print our prediction. So let's run this code. Okay, so it says this is a ham, meaning it is not a spam. So you can try this function with different input to see whether the model will be able to classify them as spam or not spam. So this brings us to the end of this project. Next, we are going to work on the breast cancer detection model. So let's create a new folder, breast cancer, and create a new file, index.pyplnb. Alright, so let's import the necessary files. We import Pandas, Matplotlib, Seaborn, the train test plate function, logistic regression, accuracy score, and standard scalar. So let's create a new code block and then load our dataset. So file path equals breast cancer data, then data equals pd.read csv of file path. So we can type data.head, which is going to print for us the first 5 rows of the data set. So we are going to use logistic regression to learn from all these columns and make a prediction whether a patient is having a diagnosis of malignant, or benign. Let's create a new code block. So there are two columns here which are not going to be useful in making the predictions: the ID column and the unnamed 32. So we are going to drop these columns and then work with the rest of the columns. So data equals data dot drop ID and unnamed 32 with the access of 1. So this is going to drop the ID column and the unnamed 32 column. So next we are going to encode the diagnosis state. In machine learning, the algorithms are not able to learn from characters or text data. So we have to convert them into a numerical data that the machine learning algorithm will be able to learn from. So in this case, we have the diagnosis in two states. We have the M and B. So we are going to encode the M to be 1 and the B to be 0. Alright, so data of the diagnosis column equals data of the diagnosis. Then we map through the entire column, and wherever we see M, we replace it by 1 and replace B with a 0. Alright, so let's create variables to separate our features and target values. So X is going to be our feature variable, which is going to be everything from the data set with the exception of the diagnosis column. So data.drop diagnosis access of 1, and then our target variable Y equals data of the diagnosis column. Alright, so let's create a new code block. So we are going to split our data set into a testing and training data set. So X train, comma X test, Y train, Y test equals the train test split function. We pass in X and Y of test size 0.2 and with random state of 42. So let's create a new code block and create a variable scalar equals standard scalar. Then we have our string variable here equals scalar.fit transform string. And then we have test equals scalar.fit test. We create a new code block to initialize our model equals logistic regression. Then model.fit train and Y train. Let's create a new code block again and create a variable of Y predict equals model.predict on the text. So next we create these variables: accuracy, confusion matrix, and report. And then we create a variable for confusion matrix, which is going to hold the confusion matrix of the Y test and Y prediction. Then we plot a confusion matrix for the model. Let's run all the code. Alright, so this is the classification report. We have 97% on precision, 99% on recall, 98% on F-score, and support of 71 for the 0 class. And for the 1 class, we have 98% of precision, 95% of recall, 96% of F1 score, and 43% for support. The accuracy of the model in general is 97%. So this brings us to the end of this project. If you enjoyed this content and found it helpful, please consider subscribing to my YouTube channel. See you in future videos.